It is my great pleasure to introduce Dr. Oz, our chemistry teacher at Topscope College. He is the head of chemistry, a dedicated educator, and accomplished scientist with extensive experience in teaching VCE chemistry. Over the past 4 years, the students have consistently achieved exceptional results, with maximum scores of 50 in 2023 and 2021, and similarity outstanding scores in 2022 and 2020. In addition to his teaching excellence, he has a strong background in scientific research, particularly in cancer research, and has worked with advanced technologies. Please join me in welcoming Dr. Oz to lead this seminar, where we will learn from the wealth of knowledge and experience. Thank you. Your turn.
Thank you for that very kind introduction. Good afternoon, everyone. I warmly welcome you to chemistry. My name is Dr. Oz, and it is my pleasure to be your host today. The overall arching goal of today's seminar is to provide you a fundamental introduction to chemistry that is inclusive to both Year 11 and Year 12. And we will be examining the prescription, which is the study design provided to us by the Victorian Curriculum and Assessment Authority. I will commonly refer to this body as VCAR, as it's the prescription that is designed by VCAR, which constitutes the chemistry study design for both years 11 and 12. So for today's agenda, I will be providing a brief introduction to myself. I will be highlighting some of my teaching experience, and I will also be talking about my scientist background prior to my career in education. But the overall arching fundamental goal today is to analyze the study design, that is the prescription provided by VCAR, and I will be examining the assessment guidelines and command terms. I will also be talking about a general preparation overview for VCE, that is inclusive to chemistry and your other study subjects. And at the very end of today's online webinar, we will have a frequently asked questions session where I will answer some of the questions that I generally get as a teacher. If you do have any questions for me, I will be more than happy to attend them in a Q&A session that I will facilitate at the end of today's talk. So if you do have any questions or queries, I welcome them. Please do kindly wait to ask this at the end of today's session. So a very quick introduction to myself, and this follows by the very, very kind and warm introduction provided by Dr. Olivia. Thank you. I am the head of chemistry. I do have extensive experience in teaching both Year 11 and Year 12, and I'm happy to share my last scores for the last 4 years where me and my team, we produced a perfect score of 50 in 2023 and 2021. And in particular, these students were coming from my class. Other scores, 47 and 49 respectively, are also very strong scores, which I'm very happy to present. I do have extensive experience in both coordinating and convening subjects. Prior to my role as head of chemistry, I have also previously been the head of Year 8 and Year 9 science respectively at my high school. A little bit more detail on my scientist background. Prior to my education background, I was a scientist for a number of years in both La Trobe and Melbourne University, where I specialized in cancer research. My research was on the basis of neuroblastoma, respectively. I have extensive experience in running and handling NMR, that is nuclear magnetic resonance, mass spectrometry, and HPLC, which is high pressure liquid chromatography. I would like to highlight for your attention that these techniques are indeed within our study design. So I'm very happy to announce that I do have extensive experience with these techniques in regards to how they work and how to problem solve with them in real life contexts. And that is particularly a passion of mine, problem solving and highlighting how what we learn actually translates to real life contexts. So I'm very passionate about chemistry, and I'm very passionate about science in general. Fundamentally, this slide, if you would like, is the take-home message for today's talk. I would like to highlight the cumulative nature of our study design. It's to be expected that there is a gradual adjustment in difficulty as you move through the concepts. This is indeed not just limited to chemistry as per se, but it's very important to understand the nature of chemistry when it comes to adjustment in difficulty. It is a prerequisite designed by VCA to undertake units 1 and 2 prior to units 3 and 4. I will further contextualize this by providing you some examples shortly, but I would like to highlight for your attention, this is one of the take-home messages for today. Our study design is indeed very accumulative. I should also highlight our design is relatively new. 2024 has been the first year of the current study design as prescribed by VCA, and both of the study designs for units 1, 2, and 3 and 4, they will continue until end of 2027. So very much relevant for the many years to come. Fundamentally, this is an extract from the study design provided by VCA. I would like to clarify that it's not an expectation for students to actually read this comprehensive document. It is more along the lines of a guideline that is provided for teachers. And I think that it's important for teachers to classify this and make this very much digestible for their students. And this is an extract that I would like to share. VCA is highlighting the fundamental nature of chemistry in regards to chemistry being a very strong prerequisite for the following subjects that you may very well wish to study in the future after year 12: engineering, medicine, nursing, pharmacy, and veterinary science. Chemistry is not only a very strong prerequisite for these future pathways and subjects, but it is a fundamental prerequisite. Understanding the nature of chemicals and chemical processes is very much a given boon should you wish to focus on these careers later down the track. So indeed, chemistry is a very strong subject, and we should appreciate that it is a very powerful prerequisite for a number of different courses. In regards to our study design, our units can be classified as follows: units 1 to 4 respectively. In regards to the cumulative nature, I would like to clarify that unit 1 is going to be the first unit that you will generally undertake. That is a prescription, followed by unit 2. It's very natural for me to say you must understand the diversity of materials before you can begin examining chemical reactions that shape the natural world around us. This is very cumulative. Units 3 and 4 follow unit 2, and please regard it in this way. You must complete unit 2 before you move on to 3 and 4 respectively. But I would like to clarify, units 4 and 3 are actually indeed interchangeable. This will very much depend on the high school that you attend to. You are actually able to study carbon-based compounds as part of Unit 4 before you examine innovation to optimize chemical processes in Unit 3. That is going to very much depend on the curriculum that is designed by a high school, but I would like to clarify that they are interchangeable, and you may very well find yourself completing Unit 4 SACs before you actually complete Unit 3. That is indeed quite a popular approach, and in the future you might find yourselves actually studying a mixture of both units as you progress along year 12. But the prescription provided definitely highlights that you must conduct unit 1 followed by unit 2. In our online webinar today, I will be further clarifying units 1 and 2, which is in your immediate agenda. Our units are further defined into respective area of studies, which can also be considered to be cumulative. Generally, you will start with area 1, which highlights chemical structures to explain properties and reactions, which is followed by how are materials quantified and classified. Area of study 3 for all your respective units is actually research-based. And this is indeed prescribed by VCA. For unit 1, Your research should be based on how chemical principles be created to create a more sustainable future. Sustainability is one of the current focuses of VCA as they continue to introduce more and more environmental principles into the study design. A key part is relating and understanding sustainability across the different topics that you study in chemistry. If I may break this down further, your area of study 1 includes the following topics: elements in the periodic table, covalent substances, reactions of metals and ionic compounds, followed by identification of mixtures via separation. In all likelihood, I would like to acknowledge that our students have likely exposure to these topics from years 9 to 10 regarding elements, bonding, covalent substances, and that's to be expected. It is very much part of the junior prescription studies provided by the general VCAR as well. But I would like to clarify, in my course that I run, the idea is to connect these ideas together to facilitate deep learning, and we facilitate that by problem solving. Area study 2 contains quantification, organic chemistry, and polymers. I would like to clarify the reason why this is a prescription and it is recommended you cover Unit 2 after Unit 1 is due to the quantification part, known as the mole concept. In all my years and experience in teaching, I consider this to be a limitation, if you would like, that is part of year 11. It is an abstract concept. It is very difficult to master, and it is very mathematical. It is very maths heavy. But please note that the maths required goes up to a year 10 level maths only. VCE mathematical skills is not required. But it is very mathematical, and it is quite the abstract topic, and I consider it to be a limitation. It is very natural to study the mole concept following your understanding of area of 1 study concepts. This is followed by organic chemistry and polymers in society, with organic chemistry being one of the larger topics that is continued in year 12. For area of study 3, as I previously emphasized, this is a research-based unit, and students will typically conduct an investigation where they may very well conduct an experiment. This is usually provided as a choice to students, and they may present their results either in the form of a poster, a scientific write-up, or perhaps a presentation. I would like to emphasize that this format is taught and assessed by using a referencing format called APA, which stands for American Psychological Association. In the course that I run in TopScope, I do provide problem solving in order to help establish mastery with the APA format, which is a requirement for this investigation unit. That concludes Unit 1. Moving on to Unit 2. Unit 2 is a natural continuation of Unit 1, and the further progress is about examining chemical reactivity of water, and a big part of this is analysis, concentration units, which is part of chemical measurement. Area of study 3, once again, remains to be an investigation-based unit where students will conduct and present their research. The concepts and topics studied as part of Area of Study 1, Unit 2, are going to be shape, behavior on water, acids and bases. This is using the lens of proton transfer, which is not the only lens to use acids bases, but it is going to be the main way that we analyze the behavior of acids and bases, followed by redox and electron chemistry, which is the counterpart to acids and bases, which uses electrons. Our students likely have exposure to acids and bases in year 9 at a year 10 level, which is very appropriate. And I would like to clarify that in my course, I provide a high degree of problem solving to relate these contexts to real life problems and to facilitate deep learning. This is inclusive to both acids and bases, which is followed by redox electrochemistry. Our Unit 2 concepts, here is another limitation factor if you would like. Concentration is also very much calculation based, which is a natural extension of the mole concept, which is of course covered in Unit 1. I consider this also to be a limiting concept in Unit 2, and this usually predetermines how well students will do in their final exams. It is quite an intricate topic. It does require lots of practice in regards to problem solving. This is followed by analysis for acids and bases, which is very, very instrument heavy, followed by measuring of gases and analysis for salts, which also utilizes measurement. And lastly, area of study 3 is once again an investigation unit. This is designed for and relevant for the topics that you will cover in Unit 2. And once again, this is where the students may find themselves conducting an experiment of their choice and presenting their scientific evidence. This may very well be in the form of a poster or a general write-up. This also utilizes APA. So it is important to take the feedback that you get from Unit 1 and apply it for Unit 2 with your continuous improvement. With the general breakdown for our Units 1 and 2 respectively, I would like to clarify the key topics that are continued at a Year 12 level, shying away from ticking all the topics that I have aforementioned. These are the key topics that naturally continue in Year 12. In particular, we must understand the nature of all the substances, whether they are covalent, metallic, or ionic, and be able to identify them from a range of different techniques that are capable of separating mixtures. You may have noticed that I have bolded the quantifying part. That is indeed about the mole concept, which is quite calculation heavy. You can expect to do more calculations at a Year 12 level. And of course, organic chemistry, which is one of the fundamental backbone topics of chemistry, is also continued in Year 12 as well. For our range of topics in Unit 2, acids and bases, redox, and analysis-based techniques are also heavy parts of Year 12. And I would like to emphasize once again, concentration and calculations will continue to be studied in Year 12 at a very deep level. But please be advised, as I highlight once again, the calculations required in chemistry go up to a Year 10 level. Any skills or content covered in VCE mathematics in methods or specialist maths are not required. Algebra up to Year 10 level is very much sufficient to facilitate these calculations at a very, very deep level. And I would like to emphasize all of these dot points are indeed prepared as part of our VCE course. Moving forward, I would like to provide a comment on the assessment guidelines and some of the command terms that are provided by VCA. This is again an extract from the current study design. I would like to continue by making a comment on the assessment and reporting part. This is a guideline provided by VCA. And what VCA wants high schools to do is they want high schools to move away from having continuous tests for their SACs and instead have a variety of assessment methods. These include critiquing an experimental design, producing a media analysis response, an investigation task, as I highlighted in the respective area of study 3s for both Unit 1 and Unit 2, analysis and evaluation of primary or secondary data. This is generally the popular choice right now. Primary data involves students getting their own data, and secondary data would be provided to students beforehand. And another example is a response to a question which may involve with the production of a selected material. This is quite explicit and provided by Vika, and it's important for you to practice and be familiar with the different types of SACs that you may very well conduct in year 11. I do provide assistance and practice for all different types that is prescribed by Vika in our VCE course. This extract highlights the different command terms that we will need to be comfortable as part of our study design. As I previously mentioned, I enjoy problem solving, and it's one of my passions to relate the chemistry that we learn to real life context. It's very important to use command terms appropriately and carefully when you do facilitate this. I would also like to clarify a range of different high schools choose to cover this in year 12. I would like to emphasize that it is to your advantage if you cover these command terms in year 11 to give you previous exposure. That is always an advantage, and we will also focus on this in our course here at Topscope College. Next part, VC preparation overview. I would like to share some personal data that I have gathered for the past 4 years. This data is inclusive to 101 students who have completed a survey for me based on the question, what was most helpful in your preparation? I have divided their responses accordingly to their final study scores obtained in year 12. This data is something that I have previously shared with my colleagues and in meetings in my high school as well. And indeed tells a very interesting story. It is very powerful. It's one thing to acknowledge that more effort will result in a better study score. That's quite a general statement that we can say for many different subjects, including the chemistry. But I particularly like the story that it tells in regards to the students who have obtained a study score of over 45 and what have they done that is quite differently compared to students that have obtained other study scores. For your attention, feedback happens to be the significant difference. Problem solving, while it's important, and facilitating practice exams, that is very important as well. Nothing to take away from them. Feedback, accordingly to my personal data that I have gathered across the number of years, remains to be the significant game changer. I contextualize feedback as reviewing mistakes, and this can come in the form of checking in with the teacher, checking in with the peers, checking in with the provided solutions, learning from your mistakes and not repeating them in subsequent assessments is the powerful tool of feedback. Using this data, I would like to clarify and provide you some general advice. Problem solving practice sacks are indeed very powerful, but feedback and reviewing your mistakes appears to be the key for a study score over 45. Some further general advice. This is quite applicable to all your subjects across the board, inclusive to chemistry. I'm going to recommend to be consistent. Please do your best and try not to leave our work to the last minute. This helps you facilitate revision consistently. This helps you prepare for your assessments in the best manner possible. Do review past assessments and do correct your mistakes. That is part of feedback. Problem solving is very powerful and it is a very important tool to help you facilitate the feedback. And regarding problem solving and reviewing feedback, all of these are inclusive and powerful tools that we will cover in our VCE course. Moving forward to frequently asked questions, these are frequent questions that I have been receiving as a VCE chemistry teacher for the past 8 years. Is it possible to undertake units 3 and 4 without unit 1 and 2? I generally receive this question at least 2 to 3 times every year. As I previously highlighted in my previous in the previous sections, this is not generally allowed. Vika provides a prescription for you to complete units 1 and 2 prior to units 3 and 4. Although the school will not ultimately stop you, you will be asked to attend panel meetings with the senior school where they will emphasize the prescriptive nature of it, which leaves you at a very, very heavy disadvantage. The next natural question is to ask, is it possible to undertake Unit 2 without Unit 1? While this is actually allowed, we must consider that this is a significant disadvantage. The prescription of concepts in Unit 2 is designed to follow Unit 1. So it is very common for students to change their subjects in Year 11 and perhaps undertake Unit 2 chemistry, and that's their introduction to the subject. But you are definitely at an advantage covering Unit 1, followed by Unit 2. Our next popular question, is it ideal to undertake biology and/or physics with chemistry? My best advice is yes, this is definitely an advantage. In regards to the concepts that we cover in chemistry, there are elements of biology, excuse me, there are elements of biology and physics within, but you do not have to necessarily undertake biology or physics to understand these concepts. Studying chemistry and practicing in problem solving within the study design is sufficient. So this is not necessary for a study score to get over 45, but I must clarify it is an advantage. And generally speaking, I do see students studying a combination of both, whether that might be chemistry and biology, chemistry and physics. It is also possible to undertake all the sciences, but it's certainly not a requirement and not the expectation from my end. Does chemistry involve graded experiments? As I previously discussed, the current study, yes, it does. Area of study 3 is the experimental component, which leads itself for students to undertake and present their research that is using the form of APA formatting. An interesting question that I tend to get from my Year 12s closer to their exam time, is it ideal to review past study design for an advantage in chemistry? The current study design is indeed new. As we implemented, it is very heavily focused on environmental chemistry, which did not appear prior to 2023. There were other content such as food chemistry that is no longer relevant for our study design. Now, reviewing food chemistry and some of the other content that is no longer in our study design, yes, this is a very minor advantage, I would like to clarify, but it is not necessary for a 40 plus score. And the reason why I'm clarifying this is a very minor advantage is because understanding other topics such as food chemistry, it will help you build your intuition to understand chemical processes. And as per our study design, that is indeed a very, very good advantage, albeit a very minor one. As I come to the end of our FAQs, when is the first session of our course? We endeavor to begin next week, which is going to be on Thursday, 18th of October. Our sessions do run for 1.5 hours, so we endeavor to make a start at 5:30 p.m., running until 7 p.m. And that comes to the conclusion of my presentation. I kindly thank you for your attention, and I'm more than happy to take any of your questions. Thank you.